Inverse of quadratic function. Determine inverse of the function y equals to x squared. Explain how you can restrict the function to ensure that its inverse is also a function. Well, in these set of videos, we are going to explore more about quadratic functions, starting with the parent function, of course. And we will learn how to restrict their domain so that we can ensure that their inverse is also a function. We'll take up some transformed quadratic functions and even quartic functions in these set of videos to apply the concepts learned. I hope you find them very exciting. So this is the first one based on the parent function y equals to x squared. Now the first part is to determine inverse of the function y equals to x squared. So let's try to do that first. Now whenever you want to find inverse of a function, then what do? You swap x and y, right? So that is how you do inverse. So inverse is, if you have x and y, just swap them. So it becomes y and x. Also remember, when you swap x and y, you're actually changing domain and range also. It also gets swapped, right? So that is what you should know. Now here, the function is y equals to x squared. Now if we swap it, we get x equals to y squared. So that is the first step. And the second step is to solve for y. Now we need to solve for y, right? So that is the next step. So when you solve for y, what do you get? You have to do square root on both sides. So whenever you do square root, you have to do square root with plus and minus sign, right? So square root of x with plus and minus sign is equals to y. So that is how we can solve for y. Now, once we have solved for y, we know the inverse, right? So we can write y inverse or inverse. We should not write f(x), we write f inverse or y inverse is actually equals to plus minus square root of x. So that is our solution, right? Now, as you can see, this inverse is not a function, right? So we know that this is not a function since it has two values, plus and minus, right? So inverse is not a function, correct? So that is what we conclude. Now if we have to draw this, how are we going to draw it? So here we do have a function which is y equals to x squared. So we have already plotted the graph for y equals to x squared. Now to draw inverse of this, what we can do is we can swap x and y values. So 0, 0, if you swap, you get 0, 0 itself. Now this point is 1, 1. So 1, 1 will give you 1, 1. These are invariant points, right? Now, the other good point which you could take now here is 2 and 4. So when you swap 2 and 4, you get 4 and 2. So you get 4 and 2. So that is the point. Now if I connect these points, I get the inverse of the right half of the parabola, right? So I can draw these and connect them like that. So that is my inverse of half the function, right? So here I could also write this is like plus square root of x. I know there's no need to write plus, but well, just to correlate, right? Now let's see the next half. 0, 0, 0, 0. And here we have minus 1 and 1. So when you swap, you get minus 1 and 1. When swapped will give you 1 and minus 1, right? So this point is reflected here. Basically what we are trying to do is reflect our graph on the line y equals to x, right? So that is the line on which we are trying to reflect the graph. Okay, so we get this point. Now let's consider the next point as minus 2 and 4. It becomes 4 and minus 2. 4 and minus 2. So that is our good point to take. Now 5 points are good enough to draw any graph. So let's connect these and draw the inverse of our function. So that becomes the negative square root of x. So in all, we see that we do have a function here and its inverse. But the inverse is not a function. Inverse is not a function since it fails the vertical line test. If I draw a vertical line, it crosses at 2 points. Therefore, it is not a function. Well, we could have seen it right from the function itself. Since if I draw a horizontal line here, then it crosses at 2 points. So we know it is not a function since the function, we can write function fails horizontal line test. That is why we know that the inverse of this function is not a function. Now let's concentrate on the second part of this question, which is explain how you can restrict the function to ensure that its inverse is also a function. So now we're talking about restrictions. How can we restrict it? So let's consider that once again. So the restrictions could be, as now you can see from our graph, if I restrict the domain from the vertex, either right side or the left side, I avoid one portion of my inverse of the function. If I avoid that, then it will pass the vertical line test, right? And therefore, we have a solution to this. And the solution is, there are two ways to do it. One is, we can say, let's consider x as greater than equal to this point, x value at the vertex is 0, greater than equal to 1. So that is one solution. Or we could say that x is less than 0 or even less than equal to, right? Either side is good enough. If I consider x greater than equal to 0, then its inverse will be the positive half. Do you see that? But if I consider x to be less than 0, then the inverse will be the negative half. So by restricting the domain of the function, we can actually ensure that its inverse is also a function. So that is how we can ensure that inverse of the function can also be a function. So the key lies in restricting the domain of the function. And the best point to select for a quadratic function is its vertex itself. So from vertex, you can select either the right side or the left side to give the maximum domain for which the inverse will be a function. I hope you appreciate it. Thank you.